Welcome to Data Engineering with Rust. In this course, Rust provides safety, speed, and low level control for systems programming, and it's covered in detail. This course teaches how to build high performance data pipelines, which you can use in data engineering, MLOps, and also traditional software engineering. What we're going to cover in this course are four key sections. First step, Rust data structures. So, what are the core features of Rust itself, including hash maps, vectors? In section Q, we cover safety, security, and concurrency with Rust. So, what are some of the key capabilities of Rust, like the Rayon library that allows you to do multi threaded programming with minimal effort? Also, in section 3, we cover popular Rust data engineering libraries and tools. Some of these include the Polars library, which is an emerging new tool for doing work with data frames and also how to deal with cloud vendors and do things like communicate asynchronously with the AWS SDK. In section 4, we get into designing data processing systems in Rust. So this gets into building real world solutions, mapping those solutions together, coordinating processes, for example, AWS step functions, or processing a data pipeline that does ETL. These are all topics covered in section 4. Now, why do we want to cover Rust? Well, Rust is a fast, memory efficient, and safe language, and it has low level control, but it also makes it easy to maintain. So it's a modern compiled language, and also with generative AI coding tools, it's a lot more approachable. What are the prerequisites? Really, a basic understanding of the Rust programming language is required for this course, but also a familiarity with data structures and algorithms is a plus. So let's dive into the course structure here in section 1 into a little bit more detail. We first get into getting started with the modern Rust development ecosystem. What this means is that doing work with pair programming tools, using prompt engineering, also learning about continuous integration. In the next lesson, sequences and maps, we get into some of the common data structures, including vectors, vecdec, also hash maps, and deal with how to build solutions in those data structures. In lesson 3, we get into more detail on data structures, including advanced data structures like graphs, priority queues, and other items like PageRank algorithms. So this really completes the core understanding of the Rust data structures for data engineering. Next, in section 2, we dive into safety, security, and concurrency with Rust. And to do that, we get into some of the core features of security and safety with Rust, like understanding multi-factor authentication, understanding encryption, understanding how to deal with mutable and immutable data structures. In lesson 2, we get into more security concepts. These include ciphers and encryption, and even incident response and compliance. Finally, in the last lesson in this particular section, concurrency, we get into some classic problems like the dining philosopher. We do some web crawling with Rayon, and we also build intelligent chatbots. In section 3, Rust data engineering libraries and tools, we first start out with dealing with Rust to manage data, files, and network storage. So building CSV files using Cargo Lambda for AWS Lambda deployment, also communicating with S3 storage via the async library that is available from AWS. In lesson 2, we get into data frames, including Rust, and also deal with notebooks. And some examples include Colab, life expectancy, dealing with polars. These are all items covered in this particular section. Now, in lesson 3, we get into cloud-based SDKs a little bit more detail, including the Google Cloud Shell with Rust, AWS Cloud Shell with Rust, Cloud9 with CodeWhisper and Rust, and also deploy some microservices with Rust. In section 4, we get into designing data processing systems in Rust, and this includes really data pipelines itself. And some of the items included are Rust AWS step functions, Rust AWS Lambda, talking about distroless, an emergent standard for containers. And then in lesson 2, we get into uh, really NLP pipelines in a nutshell. So LLMs, Onyx, Hugging Face, PyTorch pipelines, and deal with some solutions around those technologies. Finally, in lesson 3, we get into SQL and we dive into how you can use Rust and SQL together, including with SQLite, Hugging Face, BigQuery, uh, also looking at public data sets. And we also talk about some of the theory around picking the correct database. Very well with existing best practices, including DevOps. Here we have the GitHub ecosystem on the left here, and there are many amazing things you can do, like have GitHub Actions, your CI/CD server that automatically does matrix testing or linting or builds packages for you or even compile software in the case of Rust. And then you have Codespaces, which is a triggered environment specifically set up for, let's say Rust or set up for Python or set up for an existing version of Ubuntu. So you've got this containerized environment here that's really a production first mindset. Also, you use a top editor like Visual Studio Code, which is one of the most popular editors that has all of these hooks and plugins inside that allows you to be very productive. Now, once you've got all that set up, though, one of the things that you'll be seeing in the future is that you'll be using not just an AI pair programming tool like GitHub Copilot, but you also could be combining this with other tools. For example, you may first ask questions about a particular problem with ChatGPT, take that, put it into Copilot, and then finish it off. You may not like in some scenarios exactly what you got, or there is a limitation, for example, the amount of text that you could put into ChatGPT. And so you could go to another tool like Google Bard and actually double check what it's talking about, maybe even stick with Google Bard for a particular segment of your coding, maybe a 30-minute window until you get stuck. And then you actually could toggle to yet another tool, for example, AWS Code Whisper. So I think we're going to see people using lots of different resources, just like they do before AI pair programming, where you would go to Stack Overflow, Google, maybe to a learning platform to take a look at certain things. You're going to be combining all those things together to actually get the best hybrid experience when you're doing pair programming. Now, also, pay attention here that the DevOps infrastructure doesn't go away. In fact, it's even more valuable because it's the best practices that are automated so that when you do have a result from an AI pair programming tool, you can validate that those actions are appropriate. You can use linking formatting tools to clean up the results. And finally, if you're using infrastructure as code, it will programmatically deploy that to a particular environment. So really, it's not just a replacement to use these AI pair programming tools. It's actually a synergy with the existing best practices that you're using. In fact, that's the best way to use AI pair programming is to have this best practices of continuous delivery, continuous integration, and then enhance that with AI peer programming.